Hello. Standard 6.1B prime factorization. Standard 6.1B, I can find the prime factorization of an integer. So first, let's review a few things here. First, prime number is an integer greater than 1 with exactly two positive factors. 1 and the number, meaning itself, right? All right. A composite number is the other type of number. That is an integer greater than 1 with more than two positive factors. Everything greater than 1 is either going to be a prime number or a composite number. So we got to think through this first. Let's talk about that. All right. Classify each number from 10 to 20 as prime or composite. We need to come up, and how we're going to do this is we're going to talk about how do we build these numbers through multiplication, okay? So 10, I can do 10 times 1. I can do 2 times 5. Because I have more than just 10 times 1, that would make this one composite. I'm going to do this in red. All right. 11, I do 11 times 1. I can't do 2, I can't do 3, right? We could practice those divisibility rules, right? Let's see, 1 plus 1 is 2. That's not divisible by 3. It's not an even number. It's not a 5 or a 0. Yeah, this is prime. All right. 12. 12, we can do 1 times 12. I can remember that 2 times 6 makes 12, and as soon as I have a second pair, we know it's composite. 13. 1 times 13. 2 doesn't work. 3 plus 1 is 4. That doesn't work for 3. Doesn't end in 5 or 0, so this would be prime. 14. 1 times 14. And 2 times 7, so composite. 15. 1 times 15. 3 times 5, composite. 16. 1 times 16. 4 times 4, composite. All right, you're starting to get the hint here. If you can only do 1 in itself, then it's prime. Otherwise, it's composite. 17. 1 times 17 is 17. It's not divisible by 2. 7 plus 1 is 8. Not divisible by that. This one would be prime. Let's change colors. Prime. 18. 1 times 18. 2 times 9. That would be composite. 19. Prime. 20. Composite. All right. Take a minute here to look and see if you can see any patterns in what we did here. All right. Any patterns there? All right. If you didn't see one, or if you did, that's okay. Let's go to this one too, and let's take a look at this. Here's a image of the prime number chart, right? Let's note here it says shaded equals prime, right? Shaded equals prime. So let me pull it down so you can see the whole thing. Take a look at this and see if you can come up with one definitive statement about this that I shouldn't say definitive, something that feels like it's right. All right, so take a look here. I'll give you a second. Okay, so generally what people point out to us is that certain whole columns are not shaded. So look, 4 all the way not shaded, 6 all the way not shaded, 8 all the way not shaded, 10 all the way not shaded. What are those numbers? Well, 4, 6, 8, and 10 are all even numbers. We go back here to our other even number. 2 is shaded, but everything after 2 is not shaded. So one thing we can identify is that this 2 is our only even number that is prime. And that's because it's so little, there's just no other way to build it. All right? So we can then look what columns are shaded often. Let's see. Odd numbers, odd numbers, odd numbers, odd numbers are often shaded, but not always, right? Here's a composite, 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 right? So we can generally say if it's not 2 and it's even, it is composite. I mean, you can just say that. But if it's odd, we need to be able to apply a little bit more skill to it. Okay, so let's take a look here. Prime factorization. Writing a composite number as the product, meaning through multiplication, of its prime factors. I really enjoyed this. This is a fun one to do. And we're a little bit late on this, being the time of the year that it is, but I like to make these things look like Christmas trees, and that's kind of how we teach people to do it. You are allowed to pick whatever numbers you need to. Let's start with 72. I can look at 72 and see that it ends in an even number, so I know it's divisible by 2. So I'm going to start, and I'm going to do 2 on one side. And let's see, half of 72 is 36, so I'm going to write 36. And then anytime I come across using that sheet before, you'll have a copy of that at this point. using that sheet before, anytime you come across a number that's shaded on that sheet, I'm going to circle it. And I'm going to do this right away so I don't have to keep thinking about it. 2 is prime. I'm going to circle it. 36 is not prime, if you look at that sheet, which means I'm going to put another arrow underneath of it, and I'm going to keep dividing. And I like to just work with numbers I know for sure are prime. So 36 divided by 2, half of 36 is 18. 2, prime. 18, not prime. So we put an arrow. 18, 2 times 9, 2, prime. 9, not prime. So I put an arrow. 3 times 3. Hey, look, 3 is prime. So I'm going to circle both of them. And now that I have the end of every caret is circled, I'm going to rewrite that. So I'm going to write that 2 ways. I'm going to start with this one. So we're going to just write them in order. 2 times 2 times 2 times 3 times 3. You might want to pick out and cross off as you go. Like maybe I'm going to say, okay, here's a 2, cross off. Here's a 2, cross off, right? It doesn't hurt to have an order. Because what we're then going to do is we're going to group them. So I'm going to say, okay, I used the number 2. And I used it 1, 2, 3 times. Look, an exponent. Then I used 3. And I used it 2 times. There is my answer. 2 cubed times 3 squared gets us 72. And this is what your work needs to look like. Let's do it again. 120. I'm going to do 2 times... Actually, scratch that. You know what we could do? We could pick different numbers. We don't have to start with 2. How can we make 120? Well, how about... let's see. How about 4 times 30? That makes 120. So, all right. So, is 4 prime? No. Is 30 prime? No. So, then I'm going to go back and put a caret under both of them. If they're composite, we put a caret. To make 4, I'm going to do 2 times 2. Let me rewrite that so we can keep our pattern going. 2 times 2. And then we're going to say, hey, 2 is prime. So, I'm going to circle both of those. 30. I'm going to have 2 times 15. I'm going to circle the 2. And then 15 is not. I'm going to put my arrow. 15 is 3 times 5. 3 and 5 are both prime. And then I'm going to go back up here on my right. 2 times 2 times 2 times 3 times 5. I had 2 3 times. I had 3 1 time. Remember, you don't have to put the 1. I have 5 1 time. If you break these up in the other way, if I had done 2 and 60, or if I had done 15 and 8, right? I'm still going to get the same answer because they're all going to always work out the same way. These answers stick around, all right? Let's do the next one. 225. 225, that's a tough one. Let's see, I know 225 has a 5 in it. So I'm going to put a 5. 225 divided by 5 would be, you know what, let's just calculate it. I should know this one. I feel like I will by the end of this. 225 divided by 5 makes 45. All right. Is 5 prime? It's on that sheet. 5 is prime. 45 prime? No. Arrow. 5 times 9. A lot of us know that one. All right. 5 is still prime. 9 is not. 3 times 3. And 3s are both prime again. Oops. All right, so I'm going to write them back up here. And I like that. I'm going to put them in order. So I have pair of 3. So I'm going to do 3 times 3 times 5 times 5. And it's okay if you want to cross them off as you go. Just don't scribble them out. I want to see what you have. But a small cross like that where I can still read it works. All right, so now I have 3 2 times. And I have 5 2 times. So I would do 3 squared times 5 squared. Excuse me. Next one, 236. That one's tough. I don't know offhand what that one's going to be. So I tell you what I am going to do. I'm going to say, hey, it ends in an even number, so I'm going to do 2. And I'm going to get my trusty calculator out. I'm going to do 236 divided by 2 to get 118. I know that ends in an even number, so it cannot be prime. So I'm going to circle my 2. I'm going to go back and put a caret under 118. All right. I'm going to divide that by 2. 2 and 59. Right? 2 is prime. 59. I could try sometimes. Let's see. It's 59 divisible by 2. No, it ends in an even number. By 3. 9 plus 5 is 14. 14 is not 3, 6, 9. So 1 and 4 is 5. So no, not divisible by 3. Does that end in a 5 or 0? No. Man, I know there's other rules, but instead of doing that, let's hop back here real quick. We're going for 59. 59, 59. Here's, where'd the 50s go? 59, 50, 59. 59 is prime. Look at that. All right, 59 is prime. So I'm going to go back with red and circle it. And then I'm going to look and I'm going to do 2 times 2 times 59. So I have 2 squared times 59. I have to see the tree for every problem and this answer. You can skip this line of work right here. I'm going to circle it in blue. You can skip that, but you have to show me this work and this work. All right? All right, that gets us to the worksheet. Worksheet. Here you go, 6.1B, homework. Determine if each number is prime or composite. 1 through 6 is just like that first part that we did. You need to think about those numbers, decide if it's prime or composite. You also have a sheet. For 7, 8, 9, and 10, I want you to use words to explain why these numbers are composite. All right? Tell me why they are composite. For example, if I went back and went to the number 12, which is not on this list, I said 12, why is 12 composite? I could say things like, you can multiply 3 times 4 equals 12. Or I could say it ends in an even number and is greater than 2. Right? Those would be ways that you could answer. You maybe want all of those just to prove that you know it. All right. 11 and 12, you were going to do factor trees. Write the prime factorization of each number. Do the factor trees, then write that prime factorization. Remember, the prime factorization is the stuff we just talked about on the other side that we circled for each question. On the back, same thing. 6 more questions. Use your calculator. Use that prime factor chart. All right, and then again, the answers are posted. Okay? All right, your trees and your friends' trees might not match, but your answers should. So, all right, if you have any questions, let us know.